At the end of the last part of this video lecture, I asked you two questions. So here's the first of them. So we have this rod, and it moves around iron filings, but not dust or bits of paper. And is it charged? So remember that our operational definition of charged is that charged objects exert electric forces. So this rod seems to be exerting forces on iron filings. Are they electric forces? Well, electric forces are supposed to act on all objects, no matter what they're made of. This seems to be selective. It moves around iron, but not other things, so that suggests these are not electric forces. But similarly, electric forces act on all objects. There's no reason it wouldn't affect metals, and so that isn't a reason to reject this. So this certainly is behaving like a magnet. So these seem to be magnetic forces. That means the answer is not yes. Magnetic forces are not the same as electric forces. They're a different type of force. And so this thing is not charged. It seems to be magnetized. Here is the second situation that I had you think about. So again, we have this rod, and it doesn't move anything around without touching them, but it does move things that it touches. They stick to it. So is this rod charged? So again, what we're really asking is, does it exert electric forces? Well, things stick to it, so it is exerting forces. However, what it is exerting seems to be contact forces. We don't think it's magnetized because it's affecting things like pieces of paper, and a magnet wouldn't. And we see that these forces it's exerting seem to be contact forces, but electric forces are supposed to be long-ranged. So the answer is no. There is another possibility. It could just be very slightly charged so that we're unable to observe the very weak long-range forces, but when it touches things, they're close enough that we can observe the effect. However, if that was true, we would think that light enough things like dust would observably respond to it at a distance. It's time to summarize what we've observed so far and start to organize the information and draw some conclusions. So we start with a bunch of uncharged things: plastic, wool, glass, and vinyl sheets. If we rub the plastic with the wool, then we wind up with charged plastic and charged wool. And I've put them on different sides of the page. And similarly, if we rub the glass with the vinyl, we get charged vinyl and charged glass. And the reasons I've put them on the sides of the paper is that I'm trying to divide them into two categories. So first of all of these charged objects attract neutral objects. We've observed that mostly with the paper and the water. As well, they all repel themselves, and I haven't shown you charged vinyl sheets repelling charged plastic and charged glass being repelled by wool and so on, because actually the vinyl and the wool just doesn't hold its charge very well. They discharge quickly, and so it's difficult to show those. But they do repel each other. Also, the plastic attracts the wool, the plastic attracts the glass, and so on. So we have two categories now. We have the one that I've put in blue that I'll call plastic charge for now, and the other that I've put in red that I'll call glass charge for now, and we have just those two. And you might ask, how do we know we have just those two? Well, the answer is experimentally. Let's suppose there was some third type of charge. What would it be like? What would we observe? Well, it would attract both plastic charge and glass charge and be attracted by them. So that makes it seem like neutral, except that it would also have to repel itself. And we simply don't observe a third type of charge that repels itself but attracts both plastic charge and glass charge. Let's look more at the detailed properties of the forces that these objects exert on each other. So we know that the charged plastic rod will repel the other charged plastic rod. But if we only charge up one of the rods a little bit, you see I'm rubbing it only a little bit, it exerts a fairly weak force. But if I rub it more, it exerts a stronger force. So charge seems to be a quantity. It's not just that things are charged or they aren't. There's an issue of how much charge they have. And so presumably we can attach numbers to how much charge an object has. Also note that when I charge up these two plastic rods and I hold them fairly far apart, the force that they exert on each other is quite weak. But if I put them closer together, they exert a much stronger force. So the electrical force seems to decrease in strength with the distance between the objects exerting it. Now let's look at a metal ball. Unsurprisingly, the neutral metal ball and the neutral plastic rod don't exert any forces on each other. And also unsurprisingly, when I charge the plastic rod, it attracts the neutral ball. We've already seen that charged objects attract neutral ones. And also here is the glass rod attracting the metal ball. And let me just remind you that this ball is neutral. It's not attracting the glass and plastic because it's charged. It's attracted to them because all neutral objects are. So this is not a third kind of charge. But the metal ball allows us to demonstrate something new. Here it is, again, neutral and attracted to the plastic rod. But if I touch it with the plastic rod, and I have to sort of touch it a few times using different places with the plastic rod, after that, it now is repelled from the plastic rod. And I can do the same thing with the glass rod. Initially, the ball is attracted to the glass rod because it's neutral, but after I touch it in a few places with the glass rod, it is now repelled. So I can give this metal ball what we're calling plastic charge, and I can also give it glass charge by touching it with an already charged object. But something to notice about these transfers of charge from the plastic or the glass onto the metal is that they seem to be sort of unreliable. When I first touch the metal ball, it doesn't seem to have done much. The ball is still attracted. But if I touch it again with a few more places on the plastic or the glass, it eventually starts to be repelled. So I seem to have to transfer a fair bit of charge, and one touch won't do the trick. Again, I'm going to charge the metal ball using the plastic rod, so it now has plastic charge on it. And so, unsurprisingly, it's attracted to this charged glass rod. But now I'm going to touch it to the glass rod just a few times, and now it's gone back to being attracted to the plastic, and it's hard to say exactly what's happening with the glass, but it doesn't seem to be strongly repelled. So I seem to have removed some of the plastic charge on it by touching it with the glass that was charged. So these charges seem to be able to cancel each other out.
Let's see if you've been following how to use this reasoning. So let's suppose we have a plastic rod and we have some wool, and we rub the plastic rod with the wool. So now both the wool and the plastic rod will be charged. And we have a neutral metal ball. First we touch the ball with the wool, and we see that the metal ball is now charged because it attracts bits of lint and dust. So now we touch it with the plastic rod. What should we expect to observe when we test the metal ball again with the lint and dust?